Hello everyone, welcome to our first webinar of Mining Innovation across the Lifecycle series, Next Gen Mining Exploration. My name is Sam Sakasiris, the National Membership Team Leader, and I'll be your host today. Before we begin, on behalf of Austmine and our presenting companies, I would like to acknowledge that I'm hosting this webinar from the lands of the Whadjuk Noongar people. We acknowledge the traditional custodians of the various lands on which we all meet today and recognise the Aboriginal and Torres Strait Islander people attending this webinar. As the mining sector is undergoing a significant transformation driven by automation, digital systems, AI and sustainability, this six-part webinar series will dive into the critical points across the mining lifecycle. Today's webinar will explore how technologies from AI and geoscience data platforms to advanced sensing and navigation are accelerating mineral discoveries through smarter, more integrated exploration practices. Format for today's webinar consists of a presentation by each of our member presenters, followed by a Q&A session. If you do have a question for any of the presenters throughout the webinar, please type them into the Q&A box at the bottom of your screen. If your question is directed to a specific presenter, please note their name in your question. This webinar is being recorded and will be available for on-demand viewing. The presenters today, joining us today are representatives from 5 leading member companies who will share their latest innovations, insights, and real-world applications. Today's presenters are Adnan, Arslanagic, Ultimate Positioning Group, or UPG, Fabian Kohlmann from Lithodat, Kim Lawrence from Ideon Technologies, Matthew Suntup from Advanced Navigation, and Catherine Gore from Sequent. That concludes the welcome and introductions. So without further ado, I would like to welcome our first presenter, Adnan Arslanagic, Business Development Manager, Ultimate Positioning Group, Australia's top geospatial solutions provider. With a 30-year career launched in 1995, Adnan has applied various geospatial technologies to construction, mining and oil and gas industries. Having lived across Southeast Asia, Europe, New Zealand and Australia, he brings expertise from working at companies like Trimble, Fugro and Technip.
Thank you, Sam. To start with, Ultimate Positioning Group, or UPG, is a Trimble authorized distribution partner in Australia, and we are a provider of geospatial and construction solutions to mining industry. Today, I would like to introduce GuideX to you, an advanced machine guidance system for exploration and resource development activities. We will go over a few points, mainly GuideX overview and then system components and system features. What is GuideX? GuideX in a nutshell is an Australian-made end-to-end advanced machine guidance solution developed to specific requirements of exploration and resource development phases of a mine life cycle. It has been jointly developed by Trimble, which is our principal and Ultimate Positioning Group, with the collaboration of Rio Tinto, Iron Ore, and Alcoa, which were kind enough to be our industry partners in the development of this solution and share their expertise in the field of exploration and ResDev. The system in a nutshell allows a few benefits, or provides a few benefits. One, first and foremost, it provides a full and centralized data control, be it from the data prep by the organization running exploration and ResDev activities, and then going all the back into the field, providing a uniform field data collection and back into the analytics. It also serves as a single source of truth, where the data is common between both in-house and contractors team deployed on the project. In addition to that, it also provides a complete management of construction activities related to exploration and ResDev, as well as fleet management of the machines involved. Ultimately, it all ends up being a source of data that provides ultimate DMIRS compliance, whether be it in regards to clearing permits, compliance with heritage, environmental, and other aspects of your exploration permit. As every system, Guidex comprises of both hardware and software components. So for the hardware, we exclusively use Trimble technology, hence the system being powered by Trimble. And we always utilize the latest Trimble, both hardware and processing engine and correction services. All the components are ruggedized and fit for heavy machinery installation. And in addition to Trimble components, we also use in-house developed components such as industrial Wi-Fi modem routers that provide near real-time information flow between field and the office. And we also utilize Starlink technology for the machines that are working in very remote areas. Installation of the system is very straightforward and very simple. It can be installed on any type of assets, ranging from light vehicles to any heavy machinery used. And moving from machine to machine is also very simple and straightforward. When it comes to Guidex software, there are three distinct components which we are going to cover. Guidex app, or rather apps, there are two. Guidex Connect CDE platform and our Guidex DES data analytics service, which is software as a service. Guidex apps, there are two apps, namely Guidex Manager and the Guidex Field app. Guidex Manager on the operational side of the things is a desktop application that is used for creation of the Guidex project. It combines all your survey data, all your GIS data, and other sources of information to create a single Guidex project, which is then deployed into the Guidex Field app, which is installed in the machine, in the cab, and serves as the operator interface and data collection platform. Guidex Connect is a cloud service which is used for data sharing between the field and the office, and also serves as a data storage. So it utilizes various forms of communication, Wi-Fi, LTE, or Starlink, to connect the office and the machines in the field in near real time and move the data back and forth between the two. Guidex DES, or Data Analysis Service, is our office-based platform ran through the web browser, and it provides data analysis, obviously, advanced forms of data analysis, but also a 4D data visualization, and provides visual and numerical and tabular analysis of all the applications that have been done in the field. Guidex project workflow is rather simple. First, we would use Guidex Manager to create a project. Then, if we wish to, we can push all that data into a Guidex simulator, where we can perform a virtual drive-through through the data set and check for all the interactions between the machine buffer zones, other zones, and tasks that we have created. Once we are happy with that, we go and deploy that data into the Guidex app in the field, where the data is collected, and then in near real time, the data can be transferred via Guidex Connect into the Guidex DES, and then plotted and visualized and reported in near real time. What I would like to cover next is a couple of major Guidex application features. Namely, we are going to have a look at positioning, navigation and guidance, awareness, task tracking, and event recording. So when it comes to positioning, the Guidex system provides a full blend of both GIS and survey quality data and creates a very realistic 3D projects that almost look like a 3D video game from the operator interface that he can drive through a realistic 3D data set that has points, polylines, polygons, high raster imagery coming from aerial imagery or satellite imagery, and then digital terrain models. All of the data is combined together to provide a 3D visual interface to the operator, and we also support the digital terrain models and cut and fills. When it comes to point navigation, this feature is primarily used to navigate a drill rig or other sort of machine to a specific point. Typically, that would be a drill hole in a drill pattern. So we would navigate the machine to set out that position and also record the as drilled position of that collar. We can also associate the sample bag tags with particular collar and that recorded information and export that in a database. When it comes to route guidance, this is typically used to keep a line clearing machine on the track, like on the corridor, and then within the corridor and ensure that there are no breaches of the zones that machine is permitted to work within. The other guidance that we provide is awareness of the zones and machine attitude. Basically, what we do here is we provide a machine buffer, and then we look how that buffer interacts with permit zones where the machine is supposed to be and no-go zones where we want to keep the machine out of. The inbuilt IMU in our positioning platform also provides the machine attitude and gives us warning of hazardous terrain. Mainly this applies to steep slope works and hazard of machine rolling. The next thing what we do is we also control and manage all the pad and some construction activities. Typically, what we would do here is we would associate a drill pattern defined by the geologists and combine it with pad designs of various kinds, depending on whether we're doing RC, DD, or hydropad construction, and then manage all the construction tasks associated with the construction of pads and sumps. Task tracking is fully customizable and it is user defined. So we typically track all the activities, including pre-start, maintenance, and then all various steps of the construction process that you would like to track. That could be trimming, idling, line clearing, rock breaking, pad rolling, changing an implement from, say, a bucket to a rock breaker. Basically, any activity that you would like to track in terms of time and position. So as I said before, all these activities are tracked in time and in position. So they have obviously a location and a timestamp. So when all that data is imported into our DAS platform, typically via Connect in near real time, you have a full visibility and near real-time control of all the operational aspects, giving you confidence in the accuracy of data collected, as well as providing you a measure of efficiency of your operations. All that information is obviously collated, visualized, analyzed, and reported, which gives you a documented compliance to your DEMERS conditions, or rather DEMERS imposed conditions of your exploration permit. That data obviously ultimately then flows on to the other 3D modeling platforms, which are then used to provide JORC compliance reports and define the grade control of your resources. In a nutshell, this is what Guidex as a system does and how does it do. And I would just like to share quickly where we are and how we deal with the Guidex development. At the moment, Guidex is widely accepted in Australia and is used by all Tier 1, Tier 2 mining companies and a couple of oil and gas companies that use Guidex for land-based seismic explorations. We have a team of dedicated developers here in Perth. There's about 35 developers that look after development of the Guidex app itself, our Guidex Connect cloud platform, as well as our Guidex DES analytics service. Guidex DES is a light version of our other mining product called Connected Mine, which is a very wide, sort of broad-ranging DES service, amalgamating all sorts of data from any kind of mining process and correlates and reports those informations. We are the authorized distribution partner of Guidex in Australia and also worldwide. We have a couple of distribution partners in Africa and North and Latin America selling Guidex into those markets. That pretty much, I think, concludes what I had to say. I know the time is limited. We have 8 minutes, but I'm open for any questions either now, if we have time, Sam, or later on at the end of all the presentations through chat and coordinated by Sam. Thank you very much.
Yeah, thank you, Adnan. Fantastic presentation on the and a great overview of the Guidex system and how it can help all those mining companies out there. We will do the questions at the end, but obviously, as I mentioned, if it is specific to Adnan's presentation, please make sure you direct your questions accordingly. I'll move on to Kim Lawrence, Chief Experience Officer for Ideon Technologies. Ideon Technologies is a Vancouver, Canada-based subsurface intelligence company that uses the energy from supernova explosions in space to image deep beneath the surface of the Earth. Kim has been with Ideon since the company began commercial activities in 2020. Their portfolio includes customer and employee experience, brand and culture, marketing and communications, government, and community engagement. Thank you, Kim.
Thanks, everybody. I like to say I do everything but geophysics, and sometimes a little bit of that too, if I'm lucky. I'm coming to you from a beautiful Sunday evening in Vancouver, from the traditional unceded territories of the Musqueam, Squamish, and Tsleil-Waututh First Nations people here on the west coast of Canada. I'd just like to say at Ideon, we position ourselves as a company in the geosciences serving the mining industry. And what we're really trying to do is solve the geological uncertainty problem, a problem that affects all phases along the mining value chain, from exploration through to mine closure and everything in between, but especially in exploration. Just going to put all these up there for you. Oh. No. The uncertainty of understanding the subsurface, as you all know, is the dominant driver of cost, risk, and time delays in mining. And we believe that by generating unique, new, high-resolution data sets and then fusing those data sets across different domains in a quantitative way, we can understand what the uncertainty is still in the data and then how to optimize and reduce that uncertainty. And by doing this, overall, we feel we can deliver a sizable impact in the mining industry and add a lot of value to our customers throughout the life of mine, from exploration onwards. And so, as Sam mentioned, what we do is use the energy from supernova explosions to image deep beneath the Earth's surface. Sounds space age, it kind of is. I think it's pretty cool. And the way we like to explain it is using the analogy of medical imaging. So if you've ever had a kid break an arm, or you've had to go to the emergency room to get an x-ray, you know that an external energy source penetrates through the human body, is captured on the other side with an imaging sensor, and allows you to see a profile of density inside the human body non-invasively. And effectively, what we're doing is the same thing, but in the subsurface, covering millions of cubic meters at the same time and using a different energy source. And that energy source is cosmic radiation that naturally occurs all around us. That energy is in the form of a cosmic ray muon. These cosmic rays are generated when supernovas explode, and all that energy flows through interstellar space. It eventually interacts with the Earth's atmosphere and creates a shower of subatomic particles down upon us at all times. The muon is just one of those particles. You've probably heard of neutrinos, for example, is another. And they pass through the Earth's surface about once a minute for every centimeter squared. In fact, there's one that's passing through your head about once every second. What's interesting about these particles is that they travel in straight lines at almost the speed of light, and they just keep going. They're not deflected, and they lose energy progressively the deeper they go in the subsurface. And even more interestingly, as they encounter higher density material, they lose energy at an accelerated rate. So we put sensors in the subsurface to measure the directional intensity of those muons as they arrive in the subsurface, and we're able to reverse engineer effectively the density of all the material those things pass through on the way there. This is a bit of a cross-section to show you what I mean. You'll see sort of an indicative muon path here coming in from space, a subsurface mineral deposit, quite a dispersed one, and you'll see sitting beneath it, this is where our detector would be positioned, effectively capturing the muon energy as it comes through, interacts with that deposit, and then hits the sensor, either creating a pixel of quite high energy, or if it's attenuated and stopped by something dense along its path, leaving a shadow on that detector in the subsurface. We do this down to depths of 1 kilometer and beyond. And so each individual sensor that we place in the subsurface can generate a two-dimensional radiograph like an X-ray. And when we put them in multiple perspectives around a target zone, we can create a three-dimensional subsurface model. This shows you a bit about how we do that. In this scenario, we're deploying muon sensors down drill holes from surface. We can also deploy in underground mine workings at various depths. Each of those sensors images upwards towards the surface with an open field of view of about 120 degrees, capturing and measuring that directional intensity of those muons as they come in from all different directions. Two-dimensional radiographs are then created from each of those sensors, and they precisely delineate high and low density features in the subsurface. And that data is sent up to the top of the drill hole where there's a computer box that transmits that data either through cellular or satellite connectivity back to our labs in Vancouver. The radiographs are then combined to form that three-dimensional model of millions of cubic meters of Earth at one time, identifying high density anomalies such as this indicative mineralization, or also low density anomalies such as subsurface voids, caves, and sinkholes. We're solving geological uncertainty today in a number of different use cases using our Reveal subsurface intelligence platform, and ultimately addressing uncertainty in each. In exploration in particular, we believe that we can help our clients explore the target area faster, and they can focus on drilling for validation rather than drilling for discovery. We can also help reduce or optimize drilling by up to 90%. So getting more subsurface intelligence with limited time and with reduced environmental impact because you're not drilling as much. And then of course, identifying new targets, understanding their parameters, and narrowing step-out drilling plans faster. So it reduces the uncertainty of what exists between those drill holes where otherwise you might be interpolating. And that's just one of the use cases that we're currently focused on. In addition, we work across resource characterization, geotechnical mapping, and of course in caving, both block caving and sublevel cave mapping and monitoring. If you haven't connected, we did a webinar a couple of weeks ago with Evolution North Parks team about some of the work we're doing in their block caves in parks. This is what a borehole deployment looks like on a site. This is in the northern part of Canada. We use we call a spider crane to deploy down drill holes. This particular unit is being deployed in a cased PQ hole. The detectors themselves can be deployed in an uncased HQ sized hole. And then when they are deployed down hole and they stay there for typically weeks to perhaps months at a time, all you see at the surface is a capped borehole with a communications cable coming up to the computer box, the data hub at surface. We operate these in very remote areas with an autonomous power supply solution, and of course using either cellular or satellite communications. We've deployed these in the heat of Western Australia and the very, very cold northern part of Canada. This gives you an idea of what our panel format detectors look like when they're deployed in mine. So this actually helps at large facilities such as Olympic Dam, for example, and some of the caving properties where we can actually deploy these in tunnels and they image upwards, capturing data at a higher rate of speed, and we can connect those directly into mine networks. I have 3 quick case studies here that I'll just touch on briefly, knowing that you'll be getting these slides afterwards. So Vale Base Metals in Sudbury, Ontario. This is the Creighton mine. It's over 100 years old. We were asked to not only image the historic pit, but also identify any potential remnant mineralization in that mine that may have been missed as they worked the mine over the years. And so what we were able to do was deploy detectors over 6 months in 4 drill holes. And the data and insights that we gathered from that period of time was equivalent to 500 drill holes and decades of work that they'd already done on that site. We mapped areas of potential remnant mineralization to within 10 meters spatial resolution. And we imaged a 2 kilometer squared footprint around an active mine site with virtually no disruption whatsoever. And in this scenario, not only did we identify, so the magenta areas there are indicative of higher density, perhaps remnant mineralization, but we also identified a historic sublevel cave, some waste dumps on the surface, and of course the actual connection between the open pit and the mine below. Second example I'll show you is at McMillan Pass. This is in Yukon, Canada, above 60 degrees north with a company called Fireweed Metals. This is something we just completed recently. We deployed at the beginning of the winter season and imaged remotely over a period of time at minus 50 degrees in the northern part of Canada. And the idea was to gather enough data to inform the next season's drill cycle, which we did. We imaged an area that previously would have been defined by about 50 drill holes using only 3. And we measured about 600 million meters cubed, including the identification of several new drill targets that are currently being validated. And the last case study I'll share with you is Cabranor in Matagami, Canada, in Quebec. This is a property formerly owned by Glencore, now owned by Nouveau Minerals. This is the deepest deployment we've ever done of borehole muon tomography. This is at 1 kilometer depth in the Canadian Shield. We imaged over 450 million cubic meters at one go, achieving 20-meter resolution from a single hole, and identified some new areas of potential mineralization at 650 meters depth. Again, using only 1 drill hole and imaging an area that they had previously understood using 137 drill holes drilled over decades. And I will leave it at that. It's been a pleasure. Thank you so much.
Thanks very much, Kim. Amazing tech there with the X-raying of the Earth by IDN Technologies. We will now go back to Fabian, who dropped off. So Fabian Kohlmann is the Managing Director of Lithodat, an Australian geoscience data company delivering advanced digital infrastructure for geological and geochemical data. With a background in academic research and extensive experience in global exploration and data systems, Fabian leads national and international initiatives supporting open science, critical minerals discovery, and industry innovation. Thank you, Fabian.
Thanks, Sam. Yeah, I will talk today a bit about what we are doing here at Lithodat, and show you a bit the platform and how we help with your exploration workflows. So what we do essentially at Lithodat is our whole mission is to provide easy access to global spatial geoscience data, and we want to make all the data come together, being standardized and make it really intuitive and fast on-the-fly exploration of then exploration stories. So we have currently, as you can see, a huge load of different kind of very specialized data, which can help you find your deposit and looking at mineralization ages, etc. So what our other main task is essentially, it's helping de-siloing data. Though there are loads of silos everywhere, data is sitting in reports, on disks, hidden on some computers, or each team or each project has their own. Sometimes they use different units. So what we help is really bring it all together in one place. And what we do, we work with data of course, from the public domain, but also we collaborate closely with academia, with our industry partners, and with a lot of government collaborations where we help them collate all that data, bring it all together, structure it, standardize it, and then bring it in one relational database, which can then being pushed to interactive analytics platforms, including LithoSurfer. So our whole system is built to capture the whole full journey of the geological data. We have Fields app which starts capturing it in the field. You can mint IGSNs, which are PIDs to create a digital twin essentially of your sample. Then it's being stored. You can add all kind of different analytics to your data, and it all stays in one place and can be shared across the whole board with the whole team and the whole group of people. So we have a very fast and intuitive user interface. Here we see some stream sediment data from the southern part of southern Ontario. You can filter individually by different elements, by oxide. So we have developed for each different data type, different systems. We have then dashboards where you can select data. You can create your graphs on the fly. Each graph we have, you can modify individually. You can download them. You can work with the data. You see here we have dashboards for some geochemistry data. You can plot anything against anything. All our data is also available via, you can use an open REST APIs, or you can connect it to any other software you're using, let it be Sequent, Leapfrog, but you can also connect it to IOGAS or whatever. We're really platform independent. It's really about the standardization and the easy access to the data which is in the system. Then we have, of course, developed some other nice fancy tools. We have you can create SWOS profiles on the fly to analyze the relationship between elevation and the samples and analytical results you have. And as I mentioned earlier, we are the only commercial provider to offer IGSN minting service, where IGSN stands for the International Generic Sample Number, which creates a true digital twin of your actual sample, and it removes duplicates in your system from assays or other samples you take in the field. Yeah, and we have then a field app which, as I mentioned earlier, you go in the field, the team, they can take the samples, they can even mint it, you take images, you capture all your metadata, and it's already in the system, so your team sitting at home in the office, they can see the team in the field when you take samples, what's happening actually, and you can help coordinate your effort a bit better. I've prepared here a short video of the platform. So here we have some data from Canada. Those are uranium lead ages. We can have different filters per type. You see, we can filter here by age. It's very responsive, so you can on the fly filter, look at specific age ranges. Here we are looking at some old rocks, or you go down and you see it's filtering it quite fast. That's some geochemistry data in British Columbia. We can filter per element. You can do multiple filters at the same time. Here we are looking now for lithium. And if we zoom in and the whole platform is built also that you can analyze all your data straight away in 3D to look for any relationships between elevation and the potential deposit. That's the stream sediment data from Ontario, which I showed earlier. You hover over, you see all the different points and your different measurements. Here we choose now calcium. We see there is a sharp difference line between those. So if we turn on the geological maps, we see that's because of the basement in the north and the sediments in the southern part. We can change different background maps. We can choose any element and which has been measured in that suite of samples. If we change to zinc, we see there is a higher concentration in that part of Ontario. Then to investigate it further, we have, for example, developed contouring tools, so we can do on the fly contouring of your data. So you just draw the area, we can change the cell size, that's 50 meters, and that's for silver. And it does it instantly. It does IDW interpolation between your samples. So that's now for zinc, and you can do that across the whole map on the fly. And then all the data, once it's in our system, we have integrated also plate reconstruction tools. We can go back to 1.8 million with our oldest model. It goes back in 1 million year steps, so you can do the whole data you have in there can be analyzed on the fly. Here we have some deposit data combined with some mineral data, and you can see where they formed, when they formed, and try to get a better understanding, especially for subduction-related systems or porphyry copper systems that can help you with better targeting. We have a super detailed relational mineral deposit model as well, which can be filtered by any type, and can again also being connected then with any other kind of data you have and analyze that further. And yeah, the power is, if we combine that here, we see from the Tertian with the subduction, with the plate coming in, and you see how these porphyry coppers form through time. They are time dependent, and it can help you then understand the whole systems better and potentially look for new ones in other areas. So yeah, I hope that gave you a bit of an overview what is possible. There's much more doable. As I said, the software is built in a way that it can be really used with all other systems, and it just makes the whole workflow really easy and brings teams together and helps with the whole de-siloing process. Thank you.
Thank you very much, Fabian. Yeah, great to see the de-siloing of data happening, which always seems to be an issue when you want one source of truth. Next up, I'd like to welcome Matthew Suntup, Senior Application Engineer for Advanced Navigation. Advanced Navigation is a global leader in navigation and autonomous system technologies. Matthew specialises in integrating these technologies into customer solutions, enabling high-precision automation of drilling rigs and robust fleet management across mining, maritime, agriculture and space sectors. He is pioneering autonomy in GNSS-challenged environments. Thank you,
Thank you very much, Sam, and good afternoon, everybody. So as Sam said, I'm Matthew Suntup from Advanced Navigation. I'm one of our senior application engineers, and it's great to be talking today at Austmine's Next Gen Mining Exploration webinar. So I'm going to be talking a lot about automation today. I'll really be speaking about navigation technology specifically and how they're going to enable new levels of precision, autonomy, and safety for mining operations. Mining operations are continually pushing into more challenging environments, whether that's venturing deeper underground, which is what we've looked a lot at recently, operating in vast open pit mines, or managing complex fleets on the surface. We're seeing conventional navigation systems relying heavily on GNSS often fall short in these areas. Wherever these GNSS or GPS signals are disrupted, they're obstructed, or even entirely unavailable, and that could be because you're underground, because you're in a deep pit, or even if you're on the surface but you're near really large structures or other vehicles. There's a lack of reliable real-time positioning data, and that can directly impact safety, efficiency, and ultimately profitability. It's a fundamental challenge, and really it necessitates robust and resilient navigation solutions, which is where we come in at Advanced Navigation. We've dedicated over a decade to tackling these very challenges for a range of industries. Our core expertise lies in high precision and resilient navigation, and we achieve this through a combination of cutting-edge sensor technologies. So on this slide, I was actually highlighting our progression from micro-electromechanical systems, or MEMS, to fiber optic gyroscopes, or FOGs, and very, very soon, our innovative laser velocity sensor for velocity aiding. And all of these technologies are generally unlocking precision and reliability for navigation solutions at a scale that was previously just not even on the cards. We're making high-performance navigation a lot more accessible than it ever was previously. And this range is already enabling advanced autonomy across a whole variety of mining applications. Here you can see a little selection of how our different product line can actually be applied across the whole range of mining vehicles. From the Certus Evo, providing high accuracy positioning, to the Boris D90, which we designed for challenging underground environments, and then the compact Certus Mini series for light vehicles as well. Our solutions are delivering precise data needed for autonomous operations, even in the most dynamic GNSS or GPS-denied settings. Now, the solutions that we have can span that entire mining lifecycle. Wherever navigation is at play, at least, we're almost always talking about vehicles. But today I want to focus on three critical areas where precision and resilient navigation are absolutely essential. And that's going to be drill rig alignment, whether it's above or below ground, fleet management systems, and also high precision machine guidance. So We can start by briefly going over high precision machine guidance. In mining, every millimeter counts, and accurate machine guidance is going to eliminate guesswork, it reduces rework, and it optimizes material movement. Our systems are able to provide centimeter level accuracy, ensuring that vehicles can operate precisely to whatever your digital design plan is. Now, this not only is going to boost productivity, but also significantly reduces material waste and fuel consumption as well, which delivers that immediate return on investment. Skipping over to underground drill rig alignment, this is really critical in an area where you don't have any access to satellite signals and the conditions can be incredibly harsh. So when you're underground, you don't have any of the normal GPS or GNSS satellites, and traditional methods for determining vehicle orientation are often slow and expensive, but it's still critical that you know where you are and which way you're facing. Now, our Boreas range of north-seeking inertial navigation systems are able to provide an accurate alignment to true north without using any external signals. So they're not relying on satellites or even magnetic field. This leads to maximized ore recovery, reduced costs because you can actually eliminate a lot of those manual surveys you would have had to do, and also enhanced safety. And it's a fundamental prerequisite if you want to look at tele-remote or fully autonomous drilling operations or operations underground at all. Moving on to fleet management systems, efficient fleet coordination is crucial for optimizing haul routes, minimizing wait times, and maximizing overall equipment effectiveness. So our inertial navigation systems, such as Certus and that Certus Mini series, are able to provide precise and reliable vehicle positioning across your entire site. The key here is that's happening even when GNSS signals are frequently being disrupted because you're in those deep pits, or you're next to really large machinery or other structures. And this is going to ensure continuous operation, reduce downtime from lost positioning, and also support the safe integration of both crewed and autonomous assets in the same areas. Now, a lot of what I'm talking about so far are areas that we're currently selling systems to and are seeing great success in. But now I want to look into the future as well, because what we're really interested right now is how we can unlock deep underground autonomy. Recently, we conducted some successful trials at the Kallio mine in Päijärvi, Finland, as part of BHP's Think and Act Differently's Deep Mining Challenge. Now, during these tests, we applied a Boreas D90 inertial navigation system, which is one of those fiber optic gyroscopes I talked about before, and we integrated that with our laser velocity sensor prototype, which is what I was saying is coming out really soon. Now, this hybrid system demonstrated unprecedented long-duration navigation in the deep underground environment without relying on any external infrastructure. So we were getting our position above ground, driving underground, and not needing anything along the way, such as UWBs and all that. Now, I've got a visualization from this testing that we did, and it really brings to life all of these stats and everything that I'm talking about. Because as you watch this, you can actually see our systems track through that underground decline. So the Kallio mine is now closed, but it was a copper and zinc mine going down to 1,400 meters below the surface. And in this video, it's demonstrating how the Boreas D90, aided by a laser velocity sensor, was able to maintain this exceptionally precise positioning in environments completely devoid of GNSS signals. And the key thing here is that this is purely through onboard sensors on the vehicle. Again, there's no reliance on fixed infrastructure within the mine itself. This consistent performance is what's empowering real-time decision-making. It significantly enhances safety by providing operators with an accurate understanding of their position, and it ultimately drives operational efficiency in ways that weren't previously possible when we're talking about underground mining in particular. And it's this clear demonstration of how we're shaping the future of intelligent navigation in mining. In conclusion, the mining sector is really on a cusp of a new era of intelligence. High precision, resilient navigation systems, they're not just an advantage, they're actually essential for operating safely and efficiently in these really complicated environments. And in advanced navigation, we're committed to providing the innovative solutions that empower this transformation from deep underground to deep space exploration. Thank you so much, and really happy to take questions at the very end. Thanks, Sam.
Thanks very much, Matthew. Some amazing technology there with the automation that advanced navigation is bringing to the market. Lastly, I'd like to welcome Catherine Gall, Director of Mining and Metals at Sequent. Catherine leads a team of geoscience professionals in geology, geophysics and geotechnical at Sequent. With nearly 20 years experience across mining and geoscience technology, Catherine has worked in exploration, mining and resource geology and now focuses on helping customers apply Sequent software effectively to improve geological understanding and decision making. Thank you, Catherine.
Thank you to Austmine for the opportunity to be part of the Next Generation Mining Exploration webinar today. I'll be speaking today on enabling smarter exploration with a connected platform. So the exploration challenge is a familiar story. Exploration teams are capturing more data than ever before, from drilling and geophysics to geochemistry, mapping, hyperspectral scanning, drone and satellite imagery. But the data being captured is siloed across the different tools collecting it, across the different teams and even different disciplines. It's hard to access the data and it's even harder to trust. And the result of this is slower decisions, duplicated effort and missed targets. Last year, Australia invested nearly $4 billion towards discovering new and existing deposits. But without smarter systems to connect and make use of that data, we're not getting the return on investment that we should. So that challenge is being felt even more sharply now. Australia saw an 18% drop in projects, with spending falling to $530 million already in Q1 this year. And globally, investment has dropped 6% in 2024 as majors shift focus away from new discoveries. Exploration leaders are under more pressure than ever to reduce risk, compress the project timelines, and justify every dollar of spend. So in this environment, funding is hyper-competitive and exploration teams are being asked, what data do you have, where are your deposits, and what's next? And despite mounting pressure to deliver, one of the biggest barriers holding exploration teams back is data management. Teams spend far too much time on gathering their data, on cleaning it from multiple disconnected systems. And this opens the door to human error, incomplete reports, and delayed insights. Siloed data and fragmented workflows don't just slow things down. They undermine our decision quality and they quietly inflate our project costs. To overcome these challenges, we need to rethink how we connect our data and connect our workflows and make it easier to trust the information that's driving exploration decisions. Sequent's history is one of industry evolution. From the beginning, we've transformed how exploration geologists have operated by introducing groundbreaking implicit modeling technology that has changed how we interpret and understand the Earth. Now we're building on decades of that experience and our deep expertise in geosciences and software engineering. We've created Sequent Evo, which reinvents how geoscience teams collaborate, make informed decisions, and drive ongoing innovation. So Sequent Evo is an open platform that brings your data, software, and teams together, and it's backed by powerful computing capabilities. What makes it different is that it's the most advanced platform on the market dedicated to geoscience data, and it's developed by a company with a strong history in geology. It securely consolidates geoscience data from any source into one platform, so you can base decisions on reliable, actionable data. So if we look at some of the features of Sequent Evo. So Evo's geospatial search on the left makes data discovery of drilling, geophysics, geochemistry fast and intuitive by using coordinate-aware data and an interactive 3D map. It leverages cesium technology, which is also part of Sequent's parent company, Bentley Systems, ensures high performance and accurate geospatial visualization. Workspaces help exploration teams organize data by deposit or project area, so it groups all your relevant data sets together. Like checking out a book from a library, it makes it easy to find and access everything you need when working on a specific deposit. And when market conditions change, you can simply shelve the book by leaving data stored and accessible for when commodity prices improve. And we also have 3D visualization that lets you view your geoscience data side by side in one interactive cloud-based 3D scene without needing to download or import files into separate software. This allows exploration managers to quickly visualize and make decisions on exploration results. We also support and develop open data schemas, a Python SDK, and APIs, with a public developer portal and GitHub, where you'll find over 30 ready-to-use geoscience schemas, data converters, and SDK resources. You can connect your exploration data with the tools you already use. So if you want to automate drill hole QC or validate incoming geochemistry data or link to your own machine learning workflows that identify deposit anomalies, Evo makes that possible. And we've already built 2 native applications to demonstrate what's possible with that platform. So introducing Driver, one of our native apps. This uncovers local spatial trends that within drilling data, and it uses an unsupervised machine learning algorithm. It analyzes assays and lithologies, and it creates 3D and isotropy ellipsoids that reveal structural and mineralization patterns. This data-driven approach improves implicit modeling by applying quantified local trends, so it gives you a deeper and clearer understanding of your deposit geometry, and therefore can enable you to make smarter decisions around your drilling campaigns. We also have BlockSync, which centralizes block model management in the cloud. So this gives your exploration teams a more portfolio-level view of your mineral assets in one location. So it can help you prioritize your projects, but you can also track changes in grades and tons within the cloud and generate reports which you can share confidently with your stakeholders and investors. So with Sequent Evo, we're creating kind of accessible and innovative tools, and we're putting these tools directly within your hands. So one of the real benefits and value of Evo is that it's an open system. So this allows you to design bespoke workflows tailored to your projects and how your team works. So this is whether you're doing data discovery and early stage exploration, automating insights from your geoscience imagery from Imago, or modeling the more complex and deeper ore bodies with the help of Driver, or validating domains using geophysical inversions. So there's growing excitement around AI and ML and exploration. But these tools really perform best when your data is structured, reliable, and connected. Evo gives you this foundation. It's not just about storing data, it organizes it, links it, and it contextualizes it geologically. And it goes further by making it possible to connect your data into advanced analysis tools. Evo is also paving the way for more accessible advanced geostatistics for resource modeling and uncertainty analysis, starting with accessible cloud desktop hybrid workflows for conditional simulation that allow resource geologists to be more active managers of risk. So using uncertainty to drive classification decisions, scenario testing, project planning, and even investment decisions. So these just aren't R&D ideas. These are practical steps to help explorers move faster and smarter. And the platform we're building is evolving as the industry evolves. So exploration always involves risk, but your decisions don't have to be risky. Evo is a connected, centralized data and compute platform that powers faster and smarter decisions around exploration. Thanks for your time today. If you'd like to learn more or discuss how Sequent Evo can support your exploration projects, you can reach out to the Sequent team, and I can answer questions at the end of the webinar today. Thank you.
Thank you very much, Catherine. Great to see Sequent offering the industry another great product to go with the suite of products available. It's now time for audience Q&A. If you haven't already submitted a question, please use the Q&A button at the bottom of your screen. And we'll start with the questions now. I've got one from James Stewart at Always Carbon. This one's for Matthew. What is the cost of these inertia navigation units? Could they scale and replace GPS, in brackets, even where it isn't denied?
Thanks, Sam, and thank you, James. Yeah, so look, a note of cost, I was highlighting it in the talk, how there's a really big range of units, right? So we talk about having kind of entry-level units down in the MEMS, micro electromechanical system, which might be in the range of thousands, and you can go all up to the highest grade kind of fiber optic gyroscopes, looking at tens, like hundreds, right, of thousands. It just depends on what the solution you're looking for is and what you're trying to actually achieve at the end of the day. and then what reliability and all of these things you need. So really big range, and that's also a large reason why at advanced navigation, like the range of inertial navigation system is so big, because it's just different technologies with different price points. Regarding replacing GPS entirely, when we refer to inertial navigation systems, most of them actually include GPS receivers in them as well. So we even have options. We can include Trimble receivers or our own receivers in a lot of the units. And the idea is that the systems are actually complementing each other. So when GNSS or GPS is available, you're relying very heavily on that. And then as soon as you transition into another environment where it starts to be degraded, you can seamlessly switch over and start to look at all of your other onboard sensors as well. So it's not really a replacement. The idea is that everything's working together to give you something a lot more resilient.
Thanks very much, Matthew. This one's for Catherine. What is the value of capturing and organising exploration data effectively during early stage programs for the long-term success of mining operations?
Thanks, Sam. That's a great question. So from experience, a big challenge that we tend to see in mining is the loss of knowledge and understanding as a deposit moves through the different stages of mining. So from exploration through feasibility studies, and then as it moves into operations. And often those detailed insights that you gain in early exploration are in the minds of individual geologists. And as your teams change and you bring on new expertise when your operations go live, that knowledge can be lost. So we see really the value starting to capture and organize your data from the start of the process with a platform like Evo, so that not just the data is stored in an accessible platform, but the decisions that you've made on the data. So the information that went into building a model, the different hypotheses you tested and tried, and the versions and the audit history of all those decisions that you've made are all accessible and available for future teams to use as well.
Thank you very much. Matthew, another one for you. How does inertial navigation handle cumulative drift over time, especially in long duration underground operations?
Yeah, thanks, Sam. So drift is really interesting for us because once you lose an absolute reference point, so again, I was talking before about having GPS when you're above ground and not in a degraded environment, you start with GPS, then you switch away as soon as you say you go underground, you switch away and no longer have that. We tend to talk about how your position error builds up as you travel further and further. So as a percentage of, or error as a percentage of distance traveled. And the key way, I suppose, one, you minimize drift by avoiding it altogether. So when you step up to fiber optic gyroscopes, you no longer necessarily have drift in your heading at all. You can always accurately work out which way you're facing by simply measuring the rotation of the Earth itself, which is how our gyro compasses work. That's one way to avoid drift, is simply kind of going up in levels to devices that are able to rely on other things. But then you also consider what other systems you can have in place around this. So it's all about working together in harmony. If you're going around underground, you have a system which does have certain drifts in it, you could have reset points. So what we talk about with customers is having kind of your occasional surveyed in point, where whenever you get there, you can reset the whole system around it and go from there as if that was your start point, and resetting any drifts you may have experienced. It's all about kind of this hybrid, again, technology of what different things can we pull together to have a complete solution that gives you complete reliability. Thanks, Sam.
Thanks, Matthew. Catherine, another one for you. Can you elaborate more on how Driver improves the understanding of deposit geometry for exploration programs?
Yes, thanks, Sam. So Drive is probably one of the most popular applications that we have within Evo, and it uses a unsupervised machine learning algorithm that we call spatial continuity mapping. So it primarily focuses on analyzing numeric data, so anything that's assay grades, geochemistry, but can also work on geotechnical data as well. And ultimately what it does is determine the local dominant direction of continuity from a deposit. So all your assay data goes in and becomes like a data or a center point. And then Driver searches in multiple directions to assess how strongly the data points correlate. So it measures your anisotropy of of your data distribution. It then fits a three-dimensional ellipsoid around the data, so it measures your continuity and then that direction of continuity as well. So these outputs that you create, you can feed into your implicit modeling workflows within Leapfrog, and they can be applied as structural trends to guide your geological interpretations or the numeric models that go into your resource models.
Thank you very much, Catherine. I'm afraid that's all the questions we have time for today. If we didn't get to your question, please reach out to the Austmine team and we will put you in touch directly with the respective presenter. The next webinar as part of the Mining Innovation Across the Lifecycle series is the Digital Mine Plan on Monday, the 15th of September. This session explores how advanced digital technologies are shaping the way mines are designed, optimised and developed before operations even begin. To register, please visit our website, austmine.com.au. I would like to give a big thank you to Adnan, Fabian, Kim, Matthew and Catherine for sharing their expertise today. Thank you to everyone who attended and we look forward to welcoming you to the next Austmine webinar. Enjoy the rest of your day.